Hello, welcome back. Today we're going to be talking about graphing quadratics using transformations. By the end of this video, you should be able to graph a quadratic equation, again using this thing called transformations. We're going to do a brief guided discovery using our graphing calculator about the three transformations you need to know for quadratic equations. Now what I want you to do is grab your graphing calculator, turn it on, and I want you to put in x squared in y1 and x squared plus 4 into y2. Now when we graph these two, I'm going to move my cursor over to the left until it's blinking on top of that little symbol next to the y2. I'm going to press enter on that to cause that second graph to be darker. The reason I'm going to do that is it's going to help me make sure I know which graph is which here in a moment. Again, the y2, I moved it over here next to the y2 and pressed enter until it became a darker line. That way when I hit the graph button, the darker line represents what happens when we changed x squared to x squared plus 4. Now, what does adding 4 do to the graph of x squared? So here's x squared, and here's x squared plus 4. Notice the x squared plus 4 moved the graph up 4 units. It's been moved from here up 4 units. Now we can see that in the table by noticing that all of our y2 values are 4 more than our y1 values. So it shows up in the graph as the graph moving up 4. It shows up in our table as the y2 values being 4 more than all of the y1 values. So, the way we say this in math, we're always going to take our discoveries, so it's been moved up 4, and turn it into a more mathematical statement. The way we say that in math again is we shifted the graph up 4 units. That's the proper way to write the graph's been moved up. Now we're going to compare the graph of x squared and x squared minus 3. What does subtracting 3 from x squared do to the graph of x squared? Well, if adding a number moved it up, then subtracting a number probably moves the graph down. Let's take a look at a graph. So again, y1 I put in x squared, y2 I changed the line to a darker line so we can see what the minus 3 did. When we graph it, we've got our first one, x squared, and we've got our second one, x squared minus 3. Notice the minus 3 moved the graph down 3 units. How do you suppose that would look in a table? Well, if we go to our table, all of our y values, you'll notice, are 3 less than our original y1 or x squared values. y1 was x squared, y2 was x squared minus 3, and again, all the y2 values are 3 less than the y1, which again causes the graph to look like it's been moved down 3 units. The way we say this in math is we shifted the graph down 3 units. So in summary, for the equation y equals ax squared plus c, now this is the general form of the quadratic equation, we'll notice that the c, that number that we add or subtract to the ax squared or x squared, causes the graph to shift c up units up if c is positive, and c units down if c is negative. Now let's take a look at y equals x squared and y equals negative x squared. Again, I've put these in my graphing calculator, made the second one darker. Let's graph it. Here's y equals x squared, our parent quadratic function, and here's y equals negative x squared. Notice the negative x squared caused the graph to reflect in the x-axis, or over the x-axis. Now when we look at our table of values, notice again the y1 are our x squared values, the y2 are our negative x squared values. Look what causing the y2 to be negative x squared does to the x values. It changes the values from positive to negative. Positive 4 to negative 4, positive 9 to negative 9, positive 16 to negative 16. So that makes sense. When we multiply our equation by a negative number, it changes the sign of all of our y values. The way we put this in math language, again for the graph, is that we have reflected the graph of y equals x squared over the x-axis. You'll often see it also said, instead of over, in the x-axis. For our purposes, we're going to say those mean the same thing. So continuing on to our last type of transformation, we're going to compare y equals x squared and y equals 5x squared. So what does multiplying by 5 cause the graph of x squared to do? Let's take a look at the graph. Here's our x squared, and when we multiply by 5, notice it kind of looks like the values have become more narrow, like closer to the y-axis. This one's a lot harder to see on the graph, so we're going to go to the table to help us further understand, or understand better, what's actually going on with our y values. Now notice, if our original value was 1 for y1, our x squared, when we multiply by 5, yeah, it's kind of obvious, the y2 values are 5 times bigger. Let's take a look. If the y value was 4 originally for x squared, the y2 value is 20. If the y value was 9, the y2 value was 45. So what's going on is we're causing all of our y2 values to be 5 times higher. So on a graph, what you've really done is you've taken your original graph and you've stretched those values vertically by a factor of 5. You made them 5 times taller. It's called a vertical stretch. And again, the way we put that in math language is we say we stretch the graph vertically by a factor of 5. So, if your a value, the value in front of x squared, is a 5, we say we stretch the graph vertically by a factor of 5. The word factor meaning multiplication. And for our very last type of transformation, still part of this stretching thing, we're going to have x squared and y2 equals 1/2 x squared. Now I want to show you how to enter 1/2 x squared into the calculator. We can simply go 1 divided by 2 times x squared. Now, when we plot this, let me change that right there to a darker line. When we plot this, here's our original graph, and here's our graph that's been multiplied by 1/2. Now, if multiplying by 5 causes us to stretch the graph, make it taller, then multiplying by 1/2 should make it 1/2 as tall. Problem is, on a graph, it really doesn't look like the values have been made 1/2 as tall. So, to further understand, we're going to go to our table, and looking at our y1 values, we notice if y1 0, y2 0. Okay, if y1 is 1, y2 is 0.5, half as much. If y1 is 4, y2 is 2, half as much again. So we're taking our y1 values and making them half as tall. So when we graph that, we compress or shrink our y values by 1/2. Which makes it look like it's been compressed or squished a little bit towards that x-axis. In math language, we say that we shrink the graph vertically by a factor of 1/2. Now you can use the word shrink, or sometimes you'll see it written as compress. And we compress the graph vertically by a factor of 1/2. Let's take a look at a couple of examples where we're going to have to list the transformations. So we're going to list the transformations that the following equations would have on the graph of y equals x squared. Let's take a look. Y equals 3x squared minus 5. Now notice we have two things going on here. We have the 3 and we have the minus 5. We always list them in PEMDAS order, so we list our multiplication, division first, and then our subtraction or addition. So this 3 right here means we stretch by a factor of 3, and the negative 5 means we shift down by 5 units. So the 2/3 and the positive 4. Let's take a look at those. Suppose I've given you 2/3. What's the 2/3 do to the graph? The 2/3 means that we shrink the graph by a factor of 2/3 and shift the graph up 4 units. I've got several more examples here. I'm going to do number 3 for you, but then I ask you do number 4 and number 5 on your own, pausing the video and pressing play when you're ready to see the answer. So for number 3, I noticed that we have a -5, but the negative really has two different transformations, the negative portion and the 5 portion, and I also have a +1. So I'm going to use 3 different colors to list the transformations. The first thing I'm going to look at is that 5. The 5 causes the graph to vertically stretch by a factor of 5. Now, the negative causes the graph to reflect over or in the x-axis. And the 1 causes us to shift the graph up 1 unit. There you go. Go ahead and try 4 and 5 on your own, pressing pause and press play when you're ready to see the answer. Okay, for number 4, I noticed that there was a 0.5 and there was a negative, so that 0.5 made me shrink by a factor of 0.5. For right now, I'm just going to say by 0.5 to abbreviate. And the negative causes me to reflect over or in the x-axis. Since there's no addition or subtraction, it does not shift the graph up or down at all. For the 5th one, I was dividing by 3. So when I divide by 3, it's the same thing as multiplying by 1/3. That means that I shrink by 1/3, since it's the same thing as 1/3 times x squared. And the -0.1 means I shift the graph down by 0.1 units.